Lesson 3. Work, Potential. Section 3.2. Potential. This is the force F1 on the charge Q1 at point P1, where R equals R1. The electric field intensity E1 at point P1 is given by this equation. By using E1, F1 can be rewritten as this equation. The counter force FC1 is then expressed using E1. At point P2, where R equals R2, E2 is expressed by this equation. This is the counter force FC2. This is the counter force FC at a distance of R meters from Q0. The differential work dW can be rewritten in this form. Finally, the work W21 from P1 to P2 is expressed as a line integral of the electric field intensity E along L, where L2 equals R1 minus R2. The work W21 is derived as shown in this equation. The potential V21 at P2 with respect to P1 is defined as the work W21 per unit charge. V21 is given by this equation. The unit is joule per coulomb, which is equivalent to volt. If R1 goes to infinity, the potential V2 at P2 is derived as shown in this equation. The potential V at point P, R meters away from the positive point charge Q coulombs is Q over 4 pi epsilon R volts. This is the case where the potential at infinity is set to 0 volt. Let's go back to the line integral of E to obtain V21. It was expressed by this equation. This can be transformed into another form using integration by substitution. L is substituted by R1 minus R. Then the differential displacement dl is replaced with negative dr, and the interval of the definite integral is adjusted accordingly. The integral is transformed into this equation. Finally, this well-known form of the relationship between the potential and the electric field intensity is obtained. The potential V21 is derived by using this well-known integral, resulting in this equation. Exercise 3.2.1. Pause the video, and answer the problem. Find the potential at point P. The answer to exercise 3.2.1. Pause the video, and check your answer. Exercise 3.2.2. Pause the video, and answer the problem. Find the work done in moving a unit charge from point P1 to point P4 via the two different paths. Find the potential at P4 with respect to P1. The answer to exercise 3.2.2. Pause the video, and check the answer. The work W21 is done along path 1 from P1 to P2. This is the case for path 2. W42 is the work done along path 2 from P2 to P4. The total work W41 is the sum of W21 and W42. The potential at point P4 with respect to P1, denoted by V41, is derived as shown in this equation. These are the cases for path 3 and path 4. The total work W41 is the same as that through path 1 and path 2. The potentials via the two different paths are the same. Exercise 3.2.3. Pause the video, and answer the problem. Calculate the work done in moving a unit charge from point P1 to point P4 via the two different paths. Find the potential at P4 with respect to P1. The answer to exercise 3.2.3. These are the cases for path 1 and path 2. Pause the video, and check your answer. These are the cases for path 3 and path 4. Pause the video, and check your answer. Note that, in this electric field, the work done along both paths is the same. Exercise 3.2.4. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.